Microsoft Student Partners, and then into the workshop itself. So, like he said, I'm a student at Florida Polytechnic University. I'm majoring in computer engineering with a concentration in machine intelligence, which is another name for artificial intelligence. I'm also the assistant director for Phoenix Hacks. If you like to build projects, take a look. It's a hackathon, so you have 24 hours to build a project of your choice. I put some social media in there in case you want to connect with me. You can see, yeah, these three are mine: Twitter, LinkedIn, and Instagram. You're going to see me more in Instagram than anything, but feel free to connect with me in any of these. This is Phoenix Hacks and MSP USA. Florida Poly is in Florida, so in the United States, I'm considered a US MSP, even though I'm an international student, which means I'm actually from Brazil, which is where I'm speaking from right now. So give them a follow. They'll be posting and other events. Also make sure to check MSP Lahore, and which are our host today, and thank you very much, and thank you, the WomeninTech team. Can't wait to do more stuff like this with you guys. So about the program, just real quick, Microsoft Student Partners, about to be Microsoft Learn Student Ambassadors, is a program where you get to meet a lot of wonderful people, learn a lot about different technologies. I didn't know anything about machine learning until I joined the Student Ambassadors program. If you want to apply, we'll be starting the cohort. The next cohort will be onboarded by the end of this month. So go to studentambassadors.microsoft.com and you can apply over there. Okay, that's it. Just a brief introduction so we can get right on with machine learning. First, just so you guys know, just an agenda for today. I'm going to give you some machine learning concepts. Then I am going to give you two demos, one using Azure Notebooks and one using Azure Machine Learning Studio. And then at the end, I'll leave time for any questions that you may have. You can post them in the chat and I'll take a look at them at the end. So let's start with the machine learning concepts, and let me slow down a little bit. So what is machine learning? That's the first line, that's the definition, pretty much. Is a data science technique used to extract patterns from data, allowing computers to identify related data and forecast future outcomes, behaviors, and trends. So the idea of machine learning is you have some data and then you can get more data from it. You're going to understand more of what I'm talking about when we get to the examples. Some applications are personal assistants, so Siri, Google, Alexa. Self-driving cars, which if you don't know what they are, take some quick second to look it up. It is amazing. Language translation and image recognition. Also, product or post recommendation is also a form of machine learning. Let me take that example to explain you get data from data. So you have a bunch of people that buy product. Let's use makeup as an example because I just got some unit makeup. So everyone that buys powder, that buys a base, also buys the base brush. So if you buy only the base brush, you might get in your recommendations the powder. So what they have is you have already data, which is a bunch of people bought these two products together. And then when another person wants to buy one of these products, you have, hey, but you can also buy this one. You might need it too. So that's the idea of getting data from data. When we get to when we get to supervised learning, we'll see a little bit more about that. First thing, a lot of people get confused between machine learning and artificial intelligence to use them interchangeably. They're not. Artificial intelligence is the theory and development of computer systems able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. So artificial intelligence or machine intelligence, it's a field way more broad than machine learning. Machine learning is one of the parts of artificial intelligence. They're not interchangeable terms. We have many different types of machine learning algorithms. We have supervised, unsupervised, deep learning, and reinforcement learning. Before I go on and explain to you what each of these mean, let me give you the difference between algorithms and models, so during my explanation you don't end up confused. These models and algorithms, these words are sometimes used interchangeably, but they're technically not. The algorithm is what you're going to use on the data to get the model. The model is your finished product after you've run the algorithm on the data. You understand a little bit more when I get to an example. So let me go to supervised, and then when I get to the example, I'll re-explain this part. So supervised machine learning, it has labels. What do you mean has labels? The idea is you have a teacher and kind of a test. You have a correct answer in a test. There's no such thing as no answer, all the answers, because the answer is all the answers above, right? That is one answer. So the idea here is you have the correct answer. That's what we're training the model to get. We want the model to get a correct answer. We are going to be using a database which will, giving the square footage, is going to give us the price. So there is a correct answer, a correct price for that square footage. We can't give a completely different price. That's not how it works. That's in regression, which is one of the types of supervised learning. The other type is classification. Let's say you have a database that gives you the type of petals in a flower, and depending on that type of petals, you have a different type of flower. Let's say you have tulips and roses. Classification, you give to the algorithm, these type of petals is for a rose, these type of petals is for a tulip, and then when you get your model and you give the model the type of petal, a petal, it's gonna give you back what flower that came from. So that's classification. You have different classes that you can fit your data into. Unsupervised. So unsupervised has no labels. We don't have that idea of a teacher and a correct answer anymore. The idea for unsupervised is to take a look at the structure, distribution in the data to understand more about the data. I have a neat little animation I'm going to show a little bit later for unsupervised that may give you a better idea of what underlying structure, what distribution in the data does this want to look at. Deep learning. Deep learning is very interesting. One of the most known scenarios, that's the word, scenarios of deep learning is artificial neural networks, which are inspired by the structure and function of the human brain. You have different kind of neurons where the data comes through, something happens in there, you don't really know what, and then the data comes out in the other end. I'll give applications when we get to our spinner. You'll see what I mean by spinner in a second. And then we have reinforcement learning, which uses our reward system and a kind of trial and error. What do you do for you? You give to your algorithm, hey, I need you to keep the ball in the middle of the plate. If you keep the ball in the middle of a plate between this circle, then you get points. If it goes off or it falls, you're gonna lose points. What the computer is gonna do is try to make sure that he has the highest score as possible. They're gonna try to get that reward, and that's where the trial and error comes from, because the computer is gonna try it over and over and over again until he can make it. I also have a cute animation for this one, but let's look at our spinner first.
Sorry for interrupting. I guess there is a whole lot of difference between your, like, the time lag between your slides to come. Reinforcement learning came just now. Okay.
Oh,
so
is it?
If you can manage that, yeah.
Vicky, could you hear my explanation?
Yeah, but the explanation was going forward and the slides were moving back. So like we're moving slow.
Okay, so let me repeat reinforcement learning to make sure everyone understood and didn't get confused. Although I can do that with the spinner because everything is in here as well. Can you see the spinner? Or is it still in the previous slide?
Yeah,
Okay.
it just again moved to previous. It went ahead and it went back.
It's just a slight delay because even though I'm
Is it
sharing
just
my
happening
screen,
with me? Yeah, now it's again there. Like the
yeah,
picture,
that's
it's
it.
there.
There you go. So let me go over that. I'm gonna re-explain everything using this. So supervised learning. We have that idea of a teacher that's trying to get you being the model, to give her a correct answer. You have two types of supervised learning algorithms: regression and classification. We are going to be looking at, during our demo, at regression, but I'm going to explain both of them. So you can see here, forecasting, predictions, process optimization, new insights. Those are some applications of regression. The idea is you have some data, and using that data, giving that data to the model is going to give you back some other value. In our case, we're going to give the model a square footage, and it's going to give us back a price. Classification, which can be used for fraud detection, image classification, customer retention, or diagnostics, is that idea where you have different data that fits into classes. So I used the flower example before. Let me use cats and dogs now. If you give the algorithm a photo of a dog and you say, hey, this is a dog, a photo of a cat, hey, this is a cat, when you have the finished model and you give that the photo of a dog, it should tell you, oh, this is a dog. So it organizes, looks at the data that you have and puts it in a category. Then we have unsupervised learning. Clustering, it's for the animation I have is for k-means clustering, but clustering is used for customer segmentation, targeted marketing, and recommended systems. That's the animation. I'll explain while it runs. This is a specific type of clustering. So the idea for clustering is you divide into groups. In this case, you see the axis moving in order to separate the entire data into groups. And you can see that the accuracy increases as well as the little axes move. So that's the idea for clustering. You divide the data into different groups depending on how many groups you told the algorithm you want. It can be kind of a trial and error process, especially if you don't know already how many groups you need. But that's not what we're going to cover today. That's a topic for another lesson. So let me go back. On unsupervised learning, we also have dimensionality reduction. So big data visualization, meaningful compression, structure discovery, and feature elicitation. The idea is that you have, for example, you have an image in 3D, and you can make that image in 3D into two images in 2D. So let's say you have a cylinder. You can, right, I'm just going to use this, a little cylinder. This is a 3D object, but how do I make this 2D? I take the circle from the top and put it in one graph, and I take the side, which for a normal cylinder would be just a line, two lines, one for each side, and I put in another graph. And that can be used with big data to make it easier for you to visualize the data. Big data, by the way, it's huge amounts of data. Then we have reinforcement learning, used for real-time decisions, game artificial intelligence, learning tasks, skill acquisition, and robot navigation. Like I said before, the idea is you give the computer a reward for it to be able to do something. This is a very cool animation we have, which is a robot that's teaching himself how to walk. You can see there's different generations. So these were not run at the exact same time. You have generation 1, 20, 80, and 999. So It doesn't clearly put the words in here, but there is another animation that I've seen and I couldn't find to put in the slides, where you have a literal, in the rendering, you have a literal laser and the computer's running away from the laser. So for reinforcement learning, you give a punishment or a reward for the computer to do what you want it to do. A good thing about this animation and seeing the generations is we can talk about epochs before we go on to reinforcement learning. So epochs are, one epoch is one iteration through your data. So you look at the entire data once, that's one epoch. It's good for you to look through the entire data multiple times, not only once. And that's the idea here. For the first trial of the computer, it failed. You can see that generation 1 falls almost immediately. Generation 20 even handles longer. Generation 80 walks and doesn't fall, but he's walking kind of strange. And generation 999 is way better. So you'd think the more epochs you have, the better, right? No. There is an amount that is perfect. It does not mean the more the merrier. Why? Because we have a problem called overfitting. So the idea of overfitting is your model is so good at looking at the train data, the data you use to train with the algorithm to train the model, that it can't figure out anything else. So the model cannot figure out new scenarios that is not he has already been trained for. He fits the data so well, he doesn't fit any other data. And we want to avoid that. We also want to avoid underfitting, which means that the model does not fit or training or test data, none of it. New cases, old cases, already seen cases, it does not work. Generally, that happens when you choose the wrong model or you didn't give it enough epochs. Let me just explain regression real quick, and then we'll go over to Azure Notebooks and take a look at that. Let me give the slide a second to transition in case it didn't. So in regression, you find the relationship between different values. In our case, we're going to be using single variable linear regression instead of multivariable, just so we can keep it real beginner friendly. So the idea of linear regression is it uses a straight line or a plane, if it's multivariable, to describe relationships between values. If you've probably seen that formula before, point slope formula, that is the function that's used, although not in that exact format because machine learning and statistics has their own format. But that's our algorithm for linear regression. The idea is you need to find M and B. That's why your model's or what your algorithm is going to try to find to create your model. Okay. Before we go on to the demo, does anyone have any questions so far? Let me go to the teams to take a look at that. Just put it in the chat. I'll give you a minute if you have any questions to put your question down, or just a couple seconds. Just if you have questions, put it down now. If you don't want to ask now, I will come back to the screen to see questions at the end. I don't see anything. I don't see any on typing, so I'm going to go ahead and go to the demo. But if you do have any questions, put them down and I'll take a look at them later. For the demo, for this demo, we're using this data. Like I said, it's just square foot of living and the price. And this is actually from a class that I participated in called Machine Learning and Deep Learning Show. I have yet to find a better example of simple linear regression, so I'm using theirs. Vedant is actually here, so thank you for joining. They do have all their classes posted online if you want to check it out. I just wanted to talk because they were the ones that did this linear regression and the whole code. The one I did was multivariable, and I did not want to use that for something as simple as what we're trying to do here. Okay, so let me walk over Azure Notebooks and explain everything. First, what is Azure Notebooks? So you can see here is Jupyter Notebooks, but on the cloud. So you don't have to download Jupyter into your computing, and everything can be saved to the cloud. It's pretty easy to get an account. Just go to just Google Azure Notebooks. That's easier, and just sign in or create your account. For the Azure Machine Learning Studio, that process is going to be a little longer, but we'll get there when we get there. This notebook uses Python 3.6, you can see over here. You can also use other languages like R if you want to. Python is easier for me, so we're using this. First things first, you have to import the libraries. If you've seen programming before, you know what libraries is, but just in case you haven't, libraries store functions that we can use instead of having to create them ourselves. So it makes the process easier and faster for us. So here we're importing 3 libraries: NumPy, Matplotlib, and Pandas. Pandas is going to be our main one together with sklearn. Matplot will be for plotting the graph, so it's easier for us to look at our data. I just click Shift Enter and it runs, and you see the number here increments. After we import the libraries, we get the data set, which is this data set right over here. See house data.csv, house data.csv. So you call this function that imports it here, and we're set that equal to a variable called dataset. And in the same process, we're also setting our x and our y values. So one of them is going to be our square footage, the other one is going to be our price. So let me shift enter to run this. That's it. So now we have our data set and our data separated. But you don't want to use all the data you have to input the entire thing into the algorithm. Never. Always separate the data that you have into a trained data and a test data. That way you can train the algorithm, make sure that the accuracy, I'm going to explain accuracy later, that the accuracy is good before you, and to do that, you need a test data. So you take your entire data set and you separate it into train and test. Here, that's what we're doing with the train test split function. We have train and test for x and y. Now that that's done, we're going to just fit or train our model. So we're just importing the model, setting that equal to a variable, and then fitting it using our x and y train. So we're using our train part of the data instead of a test part of the data. Here, we're using our test part of the data because we're going to get the predictive values, what our model figured out as the actual result. What does the model think the result is depending on these values? So I run that. And then we can see. So these are all, you see PLT. Let me come back. Import SPLT. So this is the library you're using, Matplotlib, so that we can generate these graphs. That way, it's easier for us to take a look and understand what's happening to the data. And that's also why I chose a linear. I prefer to use single variable linear instead of multivariable, so we can take a look at the graphs. It becomes harder to graph when you have multiple variables because it can become a 3D object. And Azure Notebooks, at least, does not support this very well. So the idea is you have our training set, and then you have the test set. And then you have the model in blue. And as you can see, it's a simple line, like we said it would be. Good? We're doing good so far? Everyone understanding? Okay. Like I said before, put all questions in the chat and I'll take a look at them at the end. Okay. Now that we have our model trained, we can give data and see the result. So in this case, we're manual testing right now. Okay. that's just creating here, we're going to test. So here we just give it a random value. But here you can actually input the value. So I'll just pick something crazy and click enter, and it will give the model result, right? Let me just so we can take a look, I'm going to come here to the data. I'm going to choose this first value, 1180, so 1180. And this is the price that we should get, right? 221,900. So let me try that. 286,000. So it was quite off. So we know that we maybe did something wrong with the model. Well, how do we know for sure? Because that's only one. What if it's only that point? That's how we can use these kind of functions. I'm using R2Score to get how accurate our model is. How well was it trained? So it is a number between 1 and 0. That's what R2Score specifically give you. This was barely 50%. It could be because we didn't go over the data set enough. It could be because I chose the wrong function to use. Or it could simply be because we're thinking that this is way too simple than what it should have been. Those are some possibilities for the result. That's it for our Azure notebooks. That's it. Azure Notebooks is good if you want to use Python, but if you don't want to have to code and you have something real simple that you need to do, you can use Azure Machine Learning Studio, which is just a drag and drop that you can use. It may look different than what you've seen. You can see I'm using the classic instead of the preview. So this is the one anyone can have access to. You just have to go to your Azure portal and create. Actually, let's do that. Let me show you. So you have, in order to access this one, not this one, this one, you have to go to your Azure portal and create a workspace for Machine Learning Studio. Right. You have projects, experiments, web services, datasets, trained models, and settings. We are only going to be using datasets and experiments right now. First thing, I need to download this file and upload it to my Machine Learning Studio so that I can use it in here. Oh. So to upload a dataset, you just go to Datasets, New, from local file, choose, and then the first, right, yeah. That's it. And okay. And it's going to upload. And you can see you can put many different kinds of files in here. These are .csv, but you can have any other ones. So here it is, house data 1. I had downloaded it before, therefore the 1. But that's just the data. We're just getting our data for a project. To actually build the model, I'm going to come to experiments, click new, and blank. And that's going to take us to the designer. So that's the designer. Like I said, it's just a drag tool. You just drag the items here, you link them together, and you can build the exact same model I built here, way quicker. How to choose one or the other, it depends on what you want to do. If you're doing something simple and quick, you can use this one. If you need more control over what you're doing, I would go to Azure Notebooks. But for the demo's sake, let's keep with Machine Learning Studio. First thing, I need a data set. So I'm just going to go to Save Datasets, My Datasets, and click and drag. Release. Done. We got a data set. That's it. Now, remember, I'm not going to connect the entire data set to our model, to our algorithm. No, I need to split it into test and train. So there you go. Data transformation, sample and split data. I connect by dragging. And that's it. And here you can see you can split rows, recommended regular expression, relative expression. You can give the fractions. I'm going to leave it as it is. This one is going to be test. This one is going to be, no, this one is train. This one is test, sorry. And you can see the mini map. So if you have a really big tree for all your models, you can just look at it right like that. We split the data. We got our data set. We split the data. Now I need the models. So machine learning, initialize model, regression, linear regression. But you see how it has the places already where you have to connect? This only goes out. So I can't come to this data and connect to the model. Instead, I need the train model, and that's what I do. Connect what model I'm training with the data I'm using. The data, thank you. And you see here, this popped up when I dragged it. I have to choose what column I'm using, what column I want to find. So we want price, right? That's it. And then you click the check mark. I can run this. So let me run this. There you go. You see, you have running, you have the time it takes, and then it gets the green check mark after it's finished running. And I trained the model. I can save it can visualize, which is what we're gonna do here. So bias true, but where is our accuracy? We trained the model, but what about our test data, right? We have to test the model. We're gonna go into evaluate. Oh, no, that's later. We need to test first. Besides going through this, I can just type there and it opens up for me. Just an example. Evaluate. Oh. Completely forgot the name of the thing I need to actually get. Let's evaluate and score. Not test, score model. We have to score the model here. That's what we're gonna use with our train model and our test data. So let me run that again. You see the little, done, it's run. I can right click, score data set, and visualize. And there you go. You have the square foot living, the price, and the score labels. They aren't getting really that close. And you have statistics. There's nothing. Visualizations. There's nothing. Let's select. There you go. So you have the statistics for square living, and then you have frequency and everything. You can just play with this if you want later. But what if I want more information on the model? I can use the evaluate. model. Just connect this. That's all you need. And run. Done. I can do the same thing, right click, evaluation results, and visualize. And now I have some metrics for my entire model instead of just for a specific column. You have our error, which is how we're going to tell if our model was well trained or not. These are all different types of error. I'm not going to go over each one of them right now. But another thing why you might choose Machine Learning Studio instead of notebooks is you can just, from here, publish this as a web service. So you see this little button here, set up a web service. This one, predictive web service recommended. So it's going to set up our web services for us. And you see the thing here, transfer mates. Web service input. So it organizes itself automatically. So we have our model ready to deploy as a web service. Done. So I have our data. I have experiment, goes to this core model. The input goes as data, and this is our model that we created. And then we have the output. We can click deploy. Oh, run first. Keep forgetting to that. So it makes you run it first to make sure that it works, and then you deploy. Done. Then you can just click test, and we can just put a value here and get the value back. I click. You see here, predictive experience test returned, and then the value. So this is what I inputted, and this is our result. That's it. Okay. Azure Notebooks, I actually put Azure ML Studio. I am done with my presentation. Thank you so much for coming and watching. If you have any questions, I'll be looking at the chat right now to answer them. I'm also gonna stop sharing my screen for now. Okay. It depends. So Mali, I am gonna butcher her name. I'm sorry. Maliha Khalid asked how to deploy machine learning projects on Azure. How to deploy local machine learning projects on Azure. If you're already using Jupyter notebooks, you can just copy the whole notebook over to Azure Notebooks. For Machine Learning Studio, the process is a tad little bit more complicated, and the Classic doesn't do it as well. There is a preview version of Azure Azure Machine Learning Studio that should be coming out soon. That is better to do that. And then, of course, if you want, you can also just make your project into a model with an API and use that API to embed it to a website, for example. There are many different ways to do it with even using Azure. Any other questions? Or if you want me to try to explain more about what I just explained, also you can ask, please.
Victoria, I think
Yes.
there's some technical issue due to which some of the members can't see the chat box. So if we have any questions, so you can unmute your mic.
You can talk, yeah.
If you have any question. Vedant, are you with us?
Hi. Hi. Did you say something?
Vedant,
I
can
was
you hear
just
me?
away. I just heard my name and sorry, I was away. Sad, did you say something? Were you calling me?
Okay, Vedant, do you want to add something to the session?
Okay. Yeah, that was amazing session. Like I always love the Azure machine learning studio thing. So it's just drag and drop, and it has made everything easy. But there were days where people were talking about machine learning, how difficult it is, and there's lots of thing which goes into it and stuff. But Microsoft has really made it easy, and there are other Microsoft services as well, like cognitive services, custom vision, which again makes the image classification and neural network models very easy. So kudos to Microsoft. An amazing session, Victoria.
Thank you.
So I think that's it for today's session. So thank you, Victoria, for this wonderful session.
Thank you
And
for
also,
inviting me.
I will. Okay, thank you, Victoria. So I will share the recording with you guys, and also the slides will also be shared. So thank you everyone for joining today's session, and Victoria for this wonderful session.
Thank you. And thank you everyone for coming.
So I'm going to wrap up the session. So thank you everyone.